Mircea, and I work for a company called Cloudflare, and today I'm going to show you our experience of orchestrating network devices and our entire network with Salt. And you as well can follow these methodologies. It's nothing proprietary solution. Is everything goes into the public version of Salt in the open source. A few words about me. I'm a network software engineer at Cloudflare. I'm also a member and maintainer at the Napalm automation community. If you have no idea what is Napalm, you'll find out in just a couple of minutes. It's just a library that allows us to connect to different network devices. I've integrated Napalm in Salt. I'm also OpenConfig representative, and sometimes I put on Twitter and on my blog some voices that I hear in my head, and you can follow me on Twitter, GitHub, and whatever. I use everywhere my complicated name. I'm not very creative, as you can see. Everywhere the same thing. And this presentation does not necessarily represent the view of Cloudflare, but I have this slide here to see the scale of deployment and how important for us is Salt to keep this big network reliable, stable, and as of today, it is self-resilient. We are behind more than 7 million websites. We serve many requests every day, like 86 billion DNS queries, and we basically carry about 10% of the total internet traffic. And all of this goes through 120 data centers we have distributed around the world, which means many hundreds of network devices. In this talk, I will firstly assume that some of you are not necessarily network engineers, and I will provide a view on what is the internet, what is network device, what is network vendor, and so on. Then what are our challenges in the network teams, how we solve this using a cross-vendor API called Napalm, and how we have integrated this Napalm into Salt, and how we can use it to implement the net DevOps methodologies in our networks. And at the end, I will have a very quick example how you can implement event-driven network automation in our networks. So who is not entirely comfortable with the difference between what is the internet and what is the web? I want to remember always that internet and the web are not the same thing. Internet is the infrastructure, is the physical infrastructure that carries the traffic for the web. The internet is basically only a network of networks. I have here an image of the internet. The internet as any network can be represented using a graph. And you can see how many networks are interconnected, and more specifically in this area, you can see how one of the networks connects to the rest of the internet using one edge. What is a network now? Network is just a collection of network devices that exchange data using a wireless or cabled connection. A network device is also the access point there, but also slightly bigger devices or that big or even taller than Andrew there. In this case, the physical size of the network device is actually matters, because most of the time the bigger the network device means it has more physical ports, then it can carry more traffic. In general, the internet, the devices that are on the internet that carry the internet traffic are like that big or even bigger. From a network perspective, we need two things, at least from a network device, to be able to configure them and also to retrieve and to look what configuration it has. That meaning the list of NTP peers, the BGP neighbors, the firewalls, the OSPF, and so on. And also operational data that shows you the state of your device, and which tells you what interfaces are up, what BGP neighbors are connected, or what NTP peers are synchronized, and so on. These devices are in general produced by network vendors. You've probably heard of Cisco. Another big one is Juniper, also Arista, Brocade, and remember this name, Brocade. I will reference it later. Palo Alto, MikroTik, and so on. They are so many. Some of them I never heard in my life of them. They just pop up like mushrooms. And that's the definition of a network vendor. In general, it's a company that produces hardware and software of arguable quality. You can argue how good is the software. And on traditional network devices, they come together packed the hardware and software. And the software can run only on their hardware. Most of the time, a traditional network vendor comes with the hardware and the software, and you can't replace the software with something else. It's completely locked in. And they are mostly interested to sell you stuff and proprietary solution than useful tools. They have plenty of bugs, and not very often they fix them. And here's the question. Are they compatible and consistent? Not at all. And I will have some very quick example on how they are not compatible between them. This is just a very short configuration at the BGP level that configures one BGP neighbor on Cisco, Juniper, and Nokia. All three do exactly the same thing. They configure a neighbor. But does it look the same? They are completely different, although they do the same thing. And this incompatibility can be extended also on the operational side of looking at a network device. For example, when you want to see the state of a BGP neighbor, on a Juniper, you execute a command show BGP neighbor and then the IP address of the neighbor. And it presents you a text, just a wall of text with many details, like the description of this BGP neighbor, if the connection is established, the previous state, and so on. To see the same on Cisco, you execute a different command, show BGP neighbor and the IP address of the neighbor, and again, will present you many details, but the way they are presented is completely different. Is again a wall of text and many details that are not represented in the same uniform way like you've seen on a Juniper. The same can be extended to Arista and any other network vendor. In this case, the command is again different and the output is different as well. How you can retrieve this data? Fortunately, there are some vendors that provide you an API to interact with the device. Like Juniper has an API that is XML-based over NetConf, NetConf being a protocol standardized now in an RFC. Cisco ISXR has different flavors, XML over SSH or Telnet, which is completely unstable, and also in the last versions, XML over NetConf 1.1. After so many years, but they lack many details. And if you're lucky, and you have the right combination of hardware and software, you will get JSON over gRPC, which I understand is good, but you really have to be lucky. I'm not. Cisco IIS has no API at all, so you have to do the majestic screen scraping. You basically spawn a SSH connection to the device, execute a command like you would do on the CLI, and you get this text and you parse it. This is called screen scraping. And also some devices like NXOS, they have JSON over HTTP, or Arista again, JSON over HTTP, or HTTP, and later rest over gRPC. And the inconsistency can be expanded even more. Same vendor, same platform, same operating system, but different versions. And what is even more surprising that is during two minor versions. And also notice the versioning number, which is completely human readable and understandable. Actually, there's a whole document explaining their versioning numbers. As you can see, the output from the API that is available on Nexus is completely inconsistent. For example, this field administrative state that it says that the interface is administratively up, and that's a very important flag. is missing in Nexus 7.3. Then the hardware description, again, is different. The Ethernet speed, which could be just a number telling you how many megabits per second, or I don't know, gigabits per second. But now it's a text, and you have to parse this and look into the version number. Am I going to read this from 7.0, or I'm going to read from 7.3, and so on. Even better, sometimes they insert new fields, but not without a lot of presence of mind. To see what the API provides you, usually on the CLI you can do show LDP enables pipe JSON, but as you can see, not all the time the JSON document is valid. Or the XML, exactly the same. You send to the device an XML document, and it provides you back an error. Then, now another sensible subject. To install custom software traditionally is not possible at all on network devices that are locked in, like on Juniper. But in the last few years, some white box devices like provided by Arista or Cumulus, you can. It's sad that the operating system is very, very old. For example, on Arista EOS, on one of the last versions, the software is based on Fedora 18. And now, I think they've just released Fedora 26 or 27 already, so many years back. And to sum this up, as we've seen, we have different methodologies depending on the platform. And this inconsistency can be a real problem when you have a network that relies on many platforms. And most of the networks in the real world rely on many vendors. And this inconsistency can become a real challenge. And not only that, they have different inconsistencies when you talk about the same things, but also some vendors like to introduce proprietary details. When there are out there many industry standards doing exactly the same thing, like Cisco, although LLDP is used also on the server side, also on many other platforms, they also introduced the CDP, which does the same thing, but why not buy our solution? And here's why the network community built a library called Napalm that allows you uniformly to retrieve data and to push data to your network devices. Napalm stands for Network Automation Programmable Abstraction Layer with Multi-Volatile Support, and integrates several operating systems from Juniper, Cisco, Arista, Fortinet, and so on. And allows you, from a Python perspective, to do exactly the same when you are working with a Juniper device or Cisco or any other of the platforms supported. The only difference, for example, when you want to get the BGP neighbors that you have configured on your network device, you only need to say, hey, this is Juno's device, or this is iOS or EOS, and so on. Then the only difference then, of course, is the hostname where you can find this device, which that is very natural. And the command that you issue to get the BGP neighbors is the same. Get BGP neighbors, get BGP neighbors in both cases. The output, again, is consistent. Exactly the same structure has the output when you retrieve from a Juniper or from a Cisco device. To sum this up, we have, in general, a couple of challenges when you deal with networks that rely on many vendors. But also, we have some challenges directly inherited from DevOps on the server side when you provision new devices, or when you want to react to certain events and eventually reconfigure. These events can be internal or external from your network. And believe me, networks in general have many more events you need to react on. for example, I know, like when someone steals your the prefix you announce on the internet, this is called a root hijack, and you need to do something about it. And it would be great if you can automate this as well. Or some interfaces go down, or your BGP enables are flapping, or your optics level of the interfaces is below the threshold, and many, many others. You can react to all of this and make this completely automatic. Also is the human error when someone pushes something and has a typo in it, or when simply want to replace an equipment, and replacing equipment itself is a big problem. But imagine when you replace an equipment from Juniper with a different device from Cisco. You need to write exactly the same configuration, but translate it to Cisco. Also, to monitor. In networking, there are a couple of frameworks highly adopted, like Ansible, Salt, Puppet, StackStorm, and also Chef and some others. But those four are the most adopted. And let's have a look at Ansible, for example, is the mostly adopted framework. But Ansible contacted the network vendors, and guess what network vendors did? They created divergence. That's what they know the best to do. And they created a couple of modules that are completely incompatible. Juniper provided their modules for Juniper, Cisco for the modules for Cisco, and so on. They have different methodologies, so when you have a multi-vendor network, you will end up doing something like, oh, I'm going to run this command on a Cisco, I'm doing this way, I'm going to run on a Juniper, I'm going to do that way, and so on. And also, it lacks many features that are needed for network automation. Here's a statement of one of the most known network automation and Ansible instructors, Kirk Byers. The documentation of the Ansible core networking modules is very poor. This caused me to waste a lot of time trying to working out which arguments to use. Similarly, I was frustrated by inconsistency in the output and behavior of different modules across the platforms. I think this statement speaks for itself. StackStorm is a very interesting case because they've been bought by Brocade. Brocade is one of the big network vendors. And now they are not vendor neutral anymore. For example, if you need the professional support from StackStorm, you need to call the Brocade team now. And what is even more interesting is that Brocade itself has been bought, and I think is official now, by Extreme Networks. So it's even more fun. And now let's finally have a look at Salt. In general, the architecture of Salt, as some of you are very comfortable with already, is you have a master and a couple of minions. In general, it's a hub and spoke. You can, you have a master, a server where you install the Salt master package. And the minions, the servers that you want to manage, and you install on those servers you want to manage the Salt minion package. But on traditional network devices where you can't install custom software, you won't be able to do that. And here's where CR comes and invents the proxy minion. And the proxy minion is just a process that is able to run absolutely everywhere. And the proxy minion only needs two things: to be able to contact the master and to be able to connect to the remote device you want to manage. And the remote connection can be with over any channel you want. It can be over SSH, over HTTP, or any other. We use Napalm to connect to these devices and manage them uniformly. And we mix them together. And Napalm has been integrated 2 major releases into Salt. In Carbon, where we have introduced firstly the Napalm proxy module, plus many other execution modules for basic interaction with the network device to be able to push configuration and so on, but also to retrieve data from the NTP level BGP, to look at the routes you have learned on your network device, SNMP, and so on. The next release, Nitrogen, in this year in July, come with many other features as well. We have now different modules in most of the areas of Salt. We have engine, in Oxygen we'll also have a beacon. We have runners, we have grains, we have execution modules, we have states, and I hope I'm not missing anything. And this release, Nitrogen, is a very important one because it leverages and allows you to implement much more easier event-driven automation methodologies. And from a Salt perspective, to be able to manage uniformly all your network devices, you only need to put in a pillar a configuration like that. You only need to say the proxy type is Napalm, and then the driver being the operating system of the device you want to manage. And you can choose between Junos, iOS, IOS/IO6R, and so on. So that's the only difference you will see when you will manage network devices using Napalm. Only this field, that's all. From there on, everything is consistent and looks the same when you run a command on your network devices. In this example, we retrieve the ARP table from a Juniper device and IOS6R. As you can see, the output, the structure of the output is exactly the same. The only difference being the values that can't be the same, of course. And the same is also when you look at configuration management. You run exactly the same command, state.sls ntp, and you will deploy the change at the level of the NTP. I put this NTP example here just because it's tiny and it's very easy to be understood, but this can be extended to any other example and as much as your business logic requires. The diff is vendor specific, but this is only a diff to show you what is changed and is for the human to read this. But what happens behind is a complete abstractization and an uniform dealing with the configuration management on a device. And something else that is very important is even though the network device does not have features like rollback or to commit the config, when you apply a change and you don't want to deploy it, only want to do a dry run, is not going to change the running config. This is because in Napalm, the changes you want to push are buffered somewhere and will be actually copied in the running config or will be saved for the startup config only after you do an explicit commit, like we would do on a Juniper that has this feature. And we can then uniformly execute many other commands. For example, you uniformly execute net.traceroute on all edge devices, or you can something that is from our production network. This is how we disable the connection with Cogent in all North America, or how we execute a command show version on all Juniper routers, or if you want to be very restrictive and you want to retrieve the ARP tables only from IOS6R running 602, you can do this using the grains, or to retrieve the RPM probes only from the Juniper MX480 routers. And now let's go back a bit to this slide. I said that you can't install Salt Minion on the network devices, but that's only about traditional network devices. What about the others? There are some platforms that can be literally managed like servers. They can be white box devices like Arista EOS or Cumulus that expose the underlying operating system directly to you, and you can simply install the Salt Minion after you manage the backports and all that mess. Or you have containerized solutions you can find on IOS6R, on Cisco Nexus, only in the recent versions. However, there are some platforms where you can't manage them like servers, like Juniper, or iOS XR, the 32-bit version, iOS XE, iOS, and many, many others. Actually, most of them don't allow this yet, but I see a trend that they start pushing this forward, and to allow you to run containers. And I have here an example how you can install the Salt minion on an Arista EOS. There's a couple of commands here at the bottom is the complete document with the installation notes. Basically, only need to copy the Swix package to your flash. The Swix is just an archive built from the RPM package of the underlying operating system that allows you to install custom software. And also you will copy startup script. Then you copy the Swix to a different partition. You enable it, you run the script, and hooray, you transformed your network device into a server. And while on a server you execute a command like disk.usage to show you what's the usage on your partitions, you can execute exactly the same on Arista EOS minion. And this output is actually collected from a device from our network that is carrying a lot of internet traffic. And maybe that doesn't look extremely spectacular, but is much more important than you may think, because you have direct access to absolutely everything that your device is capable of. You can install packages, you can manage files, you can have a beacon that monitors your memory usage, and many others that you basically don't have any limits. You can do on your network device exactly as what you can do on a server. On a Cumulus Linux is even simpler. You only need to download the Salt Bootstrap script, then look into the script if you downloaded the right thing, and execute it to install a Salt minion, and that's it. Now I will switch to a different topic. I will be speaking about the Salt event bus. As some of you maybe know very well, Salt is an event-driven framework, meaning that absolutely everything that you do on the command line of Salt, when you invoke a Salt command, is going to will go through a Salt bus. And this Salt bus is pluggable, and you can externalize these events, or you can inject external events. And this is how we do. We inject an event, like in this example, that is based on syslog messages. I don't have time today to expand a lot on this, but you can follow these links, and you learn how you can ingest these events into Salt. And using this, you can, for example, deploy fully automated configuration changes by reacting, for example, when one of your NTP servers is unreachable. This structure here says that one of my NTP servers is unreachable. And the structure of this document does not depend, again, on the platform you have received it from, because it's normalized thanks to a third-party library called Napalm logs provided by the same Napalm automation community. And using the reactor system, you can react and deploy configuration changes when you have a notification from a network device that one of the NTP servers is unreachable, or something even nicer. For example, when you have a notification that interface is down, you can, for example, shut down the interface, meaning that you push a configuration change to explicitly and administratively shut down the interface, and also eventually send an email notification to one of your partners, and so on. And this happens everything behind the scenes. You don't need to do anything else manually at all. Again, I have expanded on this exact example on a blog post, if you can click on it. And now, buy my book. No, it's actually free to download. Set house there. Thanks a lot for accepting the invitation. And we did this book. We put a lot of energy and many best practices you can learn. It's a mini book that I recommend you to learn, and I hope you we'll learn many things out of it. And of course, if you have any feedback, questions, just feel free to shoot. We are on Slack. We are also on a network code Slack channel that, as of yesterday, it has 300 members. And also, SaltStack now created a community and a room, dedicated room for network devices and how to manage network devices with Salt. If you will find this useful and we will implement this, we are more than happy that you will do so. And it's also nice to contribute back to both communities, to Salt and Napalm. And for the moment, I will take some questions if you want. Yes? This one?
No, the actual generation of configs.
This one. This one?
It was for the actual open config models that generate the config when storing it in the repo.
I'm not sure. Yeah. You can tell me the slide number.
It wasn't on the slide. It's some stuff we've been working inside of this.
Oh, yes. I thought it was about my slides. Yeah, so the question is, what is OpenConfig?
Yeah, the stuff we've been working on is OpenConfig.
Yes. OpenConfig is just a way to standardize the configuration and also the operational data. They only provide the models. They don't provide you an API or something, right? I've been, as a Cloudflare, I am a member of this OpenConfig community. I've proposed some new models for the probes, but there are many others available for most of the things. Yes?
Junos is trying to push IET as their framework and trying to integrate that directly with Salt-Stack.
Yes. Junos provided something indeed, and it follows the Junos standards. I mean, if you have one of the few rare networks in the world that relies only on Juniper, yeah, you can use it. You mean to?
For example, your proxy that you run.
Yes.
I don't know how many you run. I can assume it's a large number. How have you managed your proxy?
They run on a server, and this server is managed as well using Salt. Using more specifically the regular Salt minion. The regular Salt minion manages the server, and the proxy minions manages the network. So it's quite easy. It's a state that generates the files. As you can probably know, the state SLS, you can have for loops. So you won't need to write everything manually. You will have just a for loop of, let's say, 5-6 lines. And the same will be then to manage the service of the proxy minion process, which is, again, a for loop that starts and maintains the systemd process. Yes?
So is that stored in OpenConfig when you're generating that back?
The data structure, yes. Is a YAML that follows the OpenConfig system model.
Is that the part that's in core Salt right now, or is that separate?
This is distributed as Salt formulas. This one for NDP is already added there. You can, yes, yeah, and there will be many others to come. And you basically, all you have to do is put the data, the configuration you expect in the pillar and run it. That's all. You don't need to do anything else. You can go to the Salt formulas group and look what formulas they have. Just search for Napalm, and most of them are called Napalm-something. Yes? Yes, it has some safeguards, meaning that when you want to deploy a configuration change, won't be actually applied until you don't want to be applied. And also this state, exactly this one, I mean, any state in Salt, you can put test equals true, and is going to apply the changes in the buffered config, will compute the diff, and will come back to you and will show you the diff, and will discard the config. Your device won't be affected at all when you do a dry run. Yes?
How is the data structure, who decides what it looks like? Because you have like standardized key value pair information. So one is, how do you discover what it is? And if you want to contribute to the library to write something that isn't there, how do you decide what it should be?
You mean in Napalm and this output?
Yes.
It was just a purely community-based decision. It's not complete, it's far from complete. The OpenConfig models are the most complete, but they are also quite huge. For example, if you want to get the information of a BGP neighbor, you will get a huge document, but it's absolutely complete. You can have everything you can have. Yeah, so this structure, agreed, is not complete, but is what most people use. Yes?
Is Napalm able to recognize the differences between versions of like EOS, or do you have to tell it?
Yes. Yes, it can differentiate, and you'll have this into the grains, like we have on ISXR. You have these grains will be cached. That gives you exactly the version of your device, and you can use it then either to target. And I want to see, for example, you want to run a command only on a specific version, or when you want to generate a config based on a specific version and so on. You can use the grains in many other scopes. Okay, I think that's it. Thank you.